Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. In honor of February having 29 days this leap year, I thought I'd talk a little bit about time and why it's so complicated to represent, and then look at how some time libraries can help me solve a practical time-related problem. If you look at the Python module index, you can find at least 6 modules related to time or with some functions related to time: calendar, datetime, locale, time, timeit, and zone info. In Java, there's a time package with 15 different classes related to time. Let's start with some questions to illustrate the complexity of time. If your friend tells you they were at your house yesterday at this time, were they at your house 24 hours ago? Not necessarily if you live in a place that switches between daylight savings time and standard time. If yesterday was daylight savings time and today is standard time, then they were at your house 25 hours ago. Unless at this time is after the changeover time. Complicated. The question is further complicated by the location of your house. If it's in a different time zone from the location you're in when the statement is made, then how many hours ago depends on the difference in time between the time zones. Here's one I recently wondered about. How close are Abraham Lincoln's and George Washington's birthdays to the President's Day or Washington's birthday holiday that we celebrate in the States? We celebrate the holiday on the third Monday in February. This year, that's February 19th. Abraham Lincoln was born on February 12th. George Washington was born on February 22nd. Or George Washington was born on February 11th. Both statements are correct because the United States changed from the Julian calendar to the Gregorian calendar in his lifetime, losing 11 days in the process. Washington adopted his newly adjusted birthday. So Washington has a birthday of February 11th that was recorded on his birthday, but when he was a young adult and the calendar changed, he changed his birthday to February 22nd, the adjusted date based on the new calendar. Here's one more. On what day do you celebrate Pi Day? And don't tell me you don't celebrate Pi Day. Is it March 14th, a decimal approximation of pi, 3.14? Or is it July 22nd, 22/7, the fractional approximation? If you live in the States, you write your dates as month followed by day, giving us 3.14. But if you live in Europe, you write your dates as day followed by month, giving us 22/7. There's a lot to consider with time, including time zones, how we speak, say, and write our dates and times, daylight savings time versus standard time, the different calendars that we've used throughout history and around the world, and the complicated and differing leap year rules associated with each. There are also practical measurement and representation concerns when we're talking about storing and calculating with dates using a programming language. For example, this is the documentation for the Python time module, and it says, the functions in this module may not handle dates and times before the epoch or far in the future. The cutoff point in the future is determined by the C library. For 32-bit systems, it is typically in 2038. The takeaway should be that you need to specify the functionality you need very carefully, and then research the available libraries and representations, and especially their limitations, before you start to design a solution. So let's get practical. One task that I dread is setting up my calendars at the start of the semester. I have to convert the dates from one semester to the next, taking the idiosyncrasies of college calendars into account, such as Tuesdays following a Monday schedule, Thanksgiving break, spring break, etc. Suppose I want to take a stab at writing a program that will do this for me. Let's look at the Python libraries and experiment some. Python has time, datetime, and calendar libraries. If we look at the calendar library, we can see that it will create a text or HTML calendar for us. I have a little bit of code here in which I create an HTML calendar for January of 2024 and save it out to a file. And if I open it in a browser, I get a tiny little HTML January. That might be useful for our final product. It's HTML, so we should be able to go in and edit it to include due dates. Every semester I put all of the due dates for all of my courses on a calendar for myself, so I know what grading I have and when, and so I can remind my students of upcoming assignments. It would be very cool if I could write a program to generate that calendar from my syllabi. So we'll hold on to that for a later version of the program. I need something that will take a series of dates and adjust them forward to the next semester. Let's look at time and datetime. The time module says time access and conversions, and it starts by saying not all functions are available on all platforms. It contains some important definitions. You may have heard the term epoch in your travels. The epoch is the point where time starts. It can be defined differently on different systems, but in Python's time module, the epoch is January 1st, 1970 at midnight Universal Time. A timestamp is often the number of milliseconds since the epoch. Note that in the time module, leap seconds, which are irregular and added by the International Earth Rotation and Reference System's service as needed, are excluded. Let's look at the datetime module. It immediately starts talking about aware versus naive objects, which relates to whether the object is aware of time zones. I don't need to worry about time zones in my application because my calendars do not include times, and the Eastern time zone at its current status relative to daylight savings time is assumed. Looking at available types, the date class, an idealized naive date, assuming the current Gregorian calendar always was and always will be in effect, seems like it could work. This program experiments with the date and time delta classes. I can create a date object by putting in the year, month, and day. On line 16 and 17, I'm creating two date objects, one for the start of the spring 2023 semester and one for the start of the spring 2024 semester, and then finding the difference between those two dates by simply subtracting the dates and printing it out. Subtracting the dates creates a time delta object. Let's run the program. It prints 364 days. Let's look at the next bit of the program, which is more like what I'd want to do to adjust my calendar, finding the number of days after semester start that something is due, and then calculating that difference and adding that to the start of the next semester. I'd want to confirm that both of those days are the same day of the week as well. So I'm creating the assignment date, finding the difference between that and the semester start, and then adding that to the new semester start date. I can send a date object the weekday message to get the day of the week, a value between 0 and 6, and I'm just confirming that those dates are the same. Looking at the output, this would change my assignment due on 2/19 in the 2023 spring semester to 2/18 in the 2024 spring semester, and the true is the confirmation that these are both the same day of the week, a Sunday. I think that's enough to start my program that generates a new calendar from an old. I like to build my programs incrementally, so I would start by just converting a spring to a spring, or a fall to a fall, or a summer to a summer. So a repeat of this algorithm that finds the difference between a date and the start of the semester and produces the new date by adding that difference to the start of the new semester. Okay, and I have that working on one example. I haven't tested it thoroughly yet. I'll give you a brief overview and then I'll show you the parts that come from the datetime module. So if I run it, you'll see it asks me for the start date of the old semester and then the start date of the new semester, and then the file containing the calendar of dates for the old semester. I have my calendars as MS Word documents. I had it exported as an HTML file, but that was such a mess, I thought it would be easier to just grab the column of due dates out of the table and save it in a text file. So this is the file I'm reading in. And then the program asks for an output file, and here's the output file it produced. If I compare that to the spring 2024 calendar I did by hand, the dates are correct. I'm pretty happy with that because I hate this task and I inevitably make a mistake with at least one date in one course calendar. Now, the date parts of this are really simple and straightforward. We're not dealing with time, so we don't have to worry about time zones or daylight savings time. I call this function getFullDate to get the dates from the user, and in the function I parse that input and convert it to a date object which I return. So I have a date object for each of the semester start dates. Then I open the calendar and read the lines into a list using relines. Then I iterate over the calendar list and use the re module to find the dates. My regular expression is quite simple because I know what format I use to write dates. It's always just month/day. There might be more than one date on a line, as in when I have a quiz open for a couple of days for my students. So I'm using re.findIter to get an iterable so I can iterate over all the dates on a line. I'm then converting the old dates to the new dates. This is the algorithm from Date Experiment. I'm just finding the number of days, the difference between the old assignment and old semester start, and then adding that to new semester start. So if there's an assignment due on day 14 of the semester in 2023, it will be due on day 14 of the semester in 2024, whatever day that is. And then I'm just replacing the line in my list with a string representing the new date. Notice that I can access day, month, and year fields from the date object. So I can just pull the month and day out of the date, convert them to strings, put a slash between them, and stick them in the new calendar line. Well, that's my overview of how complicated date and time is, plus the start of a little project for myself. I hope you found it interesting and that it helps you with your own date and time projects. As always, have fun and keep coding.